Hello and welcome to Scholar Fedu. This is our UTME prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we are looking at the UTME questions for physics for the year 2019. This is the second and the concluding part of the recording. We are going to look at the last 20 questions that are structured for this year. Before we continue, please don't forget to subscribe to our YouTube channel, like and share our videos, and you can also leave a comment in the comment section, and also check out our website at scholar.com to pass the UTM exam for free. Alright, the first question that we have here is on fluid properties. The easiest way to reduce viscosity, that is fluid friction, of any liquid is by applying high temperature. Okay, applying high temperature to a liquid is going to reduce its viscosity, because it will make it will agitate the particles in that medium. It will make them more mobile. Okay, and when that happens, then it will be easy to overcome viscosity. Next, on density. The density of a liquid is 7.0 times 10 raised to the power 3 kilogram at 10 degrees Celsius. Find its density at 10 degrees Celsius if the cubic expansivity of the liquid is 6.5 times 10 raised to the power minus 5. Alright, so you're given the density of the liquid, okay, the initial density at 10 degrees Celsius. We are given to be 7.0 times 10 raised to the power 3, and the temperature is 10 degrees Celsius. Now the new temperature, okay, the new temperature is 10 degrees Celsius as theta 2. We look at what is the change in the temperature here. The change in temperature is the new temperature minus the original temperature. So we have 100 minus 10 degrees Celsius, and that is equal to 90 degrees Celsius. Now recall that density, the formula for density, is equal to the mass of the object divided by its volume. Okay, if we make the volume the subject of the formula here, so that means that we would let me show this. So we have, so here we have density is equal to mass m, okay, over volume v. So I want to make this volume solid. I can just bring this volume here. I'll bring the volume here, then bring this density, bring it here. That is a kind of like cross multiplication, but this is like partial cross multiplication. So bring the volume here, it will become v, okay, is equal to the mass over, and you can bring the density down here. So this will just be density. So you can cross change them like that. You can cross change them like that. Okay, but you cannot change like from here to here, kind of, no. But you can change them in a cross like that. So that's what we've done here. So we have the velocity now to be equal to the mass over the density. Okay, now for the initial condition, because there are two conditions here now: density at this temperature and then another density at this temperature. So we just say the original volume, let's say that is v1, okay, is equal to the mass m over the density, like this density here, the initial density. Then the new volume is now going to be v2 equals mass over the new density, okay, which is what we are required to find. Now next is we are going to look at we want to calculate the change in the temperature, the change in the volume rather, the change in the volume of that of the liquid. So we have the cubic expansivity here as 6.5 times 10 raised to the power minus 5 is equal to change in volume over the original volume v1 times 90. Okay, now this 10 raised to the power minus 5 means, it simply means 1 over 10, okay, raised to power 5, and 10 raised to power 5 means 10 times multiplied by itself like 5 times, and that will give you 1 over 1, 1, 2, 3, 4, okay, and 5. So that's 1 divided by 100,000, and that will give us this, okay, times 6.5. So we have 0.000065 equal to change in volume over the original volume times 90. Then when you cross multiply this, okay, we are going to have this, that is this thing here that you have here, times 90 is going to give you this, okay. Then you have v1. Now the change in volume is the new volume v2 minus v1, so you are bringing that here now. For change in volume, we are replacing it with this, the new volume minus the original volume. Now if I bring this here, if I bring this v1 here, that's the original volume, so I'm going to have the new volume v2 to be equal to what I have here already, plus, this is minus v1. When it comes here, it becomes plus v1. So I have this now. Now since it's v1, I'll just add the coefficient. The coefficient here is 0.02925. the coefficient of this one here is 1. Okay, so just add this 1 to this, and this becomes this. Okay, so we have v2, the new volume, to be equal to 1.02925 times the original volume. Okay, that's what we have now. So back to what we have here, we now say v2. Okay, remember that v2 is this thing here, m over the new density. We now say it is equal to the value of your v2, which is this, okay, v1. Now instead of writing this v1 here, remember that we have created an expression for v1 here as m over, okay, the original density. So you are replacing this v1 here by this thing here, okay, by what you have here. Alright, so next here, we can cancel out the m on this, on both sides. We can cancel out this m like this. We can't divide, we can divide like this. Okay, so when we cancel out, that means we are going to have 1 over this is equal to this. Then when you cross multiply, that is, this multiplies this. I now use this one here to multiply what you have here. So 1 times this is going to be 1 times this. What we are doing here is this, instead of this, excuse me. Okay, so what we are going to do is bring this, multiply this like this. Okay, multiply this way. So you are going to have 1 times this, then bring this number here, bring it down here. Okay, and multiply this. So we are doing like 3 multiples here. So multiply 1 by p2, then bring this one here. Okay, bring this here and this here. So you have p2 to be equal to p1, the original density, over this value here. And our p1 from the question, the original volume, was 7.0 times 10 raised to the power 3. So we bring that back, divided by 1.02925. So when we divide, we have 6.8 times 10 raised to the power 3 kilograms per meter cube. Next, when a sound wave goes from air to water, the wave property that does not change is the frequency of a wave does not change when it moves between two media. When it goes from one medium to another medium, it doesn't change. Next, on optics, an ant is found under a regular glass slab of thickness 10.0 centimeter and refractive index 1.7. Calculate the apparent displacement of the ant if viewed vertically from above the slab. So the refractive index, okay, the formula for refractive index is view depth over apparent depth. There are many formulas, but the one that is applicable here, okay, that applies to this question, is this one that we have here. The refractive index, denoted by this symbol, okay, not exactly n, is equal to view depth over apparent depth. Now here, so we've been given the thickness of that slab, okay, like the real height of the slab, or the real depth of whatever is on the other end of the slab. That's 10.0 centimeter. So what we are going to calculate here now is the apparent depth. We are going to put the apparent depth. So the apparent, how do you get the apparent depth? Now we said that the refractive index, okay, I want to show this here. The refractive index is equal to view depth over, let's say, apparent depth. And now I want to get the apparent depth. So what I'm going to do is cross multiply this like this and bring this down here. We've done a cross multiplication like this before, partial cross multiplication. So just bring this here and bring this here. So interchange them like that. So I'm now going to have the apparent depth. The apparent depth will now be equal to the view depth divided by the refractive index. Okay, so the view depth, that is 10.0. So divide it, okay, this is divided by 1.7, that will be 5.9 centimeter. Now the apparent displacement is now going to be equal to the real depth minus the apparent depth, and the real depth here is 10 minus the apparent depth, which is 4.9 centimeter, and so we have this to be equal to 4.1 centimeter. Next question on electricity: the work a 300 watt electric grinder can do in 100 seconds is. So the formula for work is power times time. Okay, power times time. The power here is 300 watts and the time is 100, so we have 300 times 100, and that is equal to 30,000. If we write this in standard form, that will be 3 times 10 raised to the power, we have 4 zeros here, so this will be 10 raised to the power 4 joules. Next, also on optics, an object is placed 15 centimeter in front of a concave mirror of radius 40 centimeter. The image formed is. So what we have to determine is, one, the nature of the image. You have to determine the nature of the image, also the distance of the image from the mirror. Okay, so to define that, we'll be using our lens or mirror formula. Okay, so the object distance, that is the distance of the object from the mirror, is 15 centimeter, and the radius of curvature of that mirror is 40 centimeter. We can use this to get our focal length. Okay, the focal length is going to be half of the radius of curvature. Half of the radius of curvature. So the radius of curvature here is 40 centimeter. We find half of this, or we say we divide this by 2. So when you divide this by 2, you get 20. So that means that the focal length of that mirror is 20 centimeter. So then get the image distance, the size of the image, okay, which is denoted as V. We use the lens or mirror formula. So you have 1 over F is equal to 1 over U plus 1 over V. So you have 1 over V is equal to that's if you make this the subject of the formula, you just bring this one here to this side, bring this to this side. Okay, when this comes to this side, it becomes minus. So you're going to have 1 over F minus 1 over U is equal to 1 over V, and you can write that as 1 over V equals 1 over F minus 1 over U. Now from here, so we have 1 over V is equal to 1 over F, which is 20, the focal length, minus 1 over U, which is the object distance, that is 15. So we have 1 over V is equal to, okay, if you take the LCM of 20 and 15, okay, that should be 60. Okay, but another way you can actually do this is to just multiply these two together, just the 20 times 15, and that is 300. Okay, which is what we've done here. Okay, but the best thing to do is actually take the LCM. So this is 300, and we're still going to get the same thing either ways. So we are going to have 20. Okay, or let me write that out. Okay, let me have that written. So that means that if you take the LCM, you are going to have, the LCM is going to be 30. Okay, it will be 30. Then you say 20 in 30, that is 3. Really it will be 60 rather. Okay, this would be 60. Sorry. So 20 in 60 is 3. 3 times 1, you are going to have 3. Okay, minus 15 in 60, that is 4, times 1, you are going to have 4 here. So you are going to have 3 minus 4, and that is minus 1 over 60. So you see we are getting the same thing as what we have here, but this one is easier, so this is what I recommend that you do. So now if you now to get our V here, okay, we can just switch, like invert both sides, that is this one over V, just turn it upside down, so it will become V. Okay, it will become V over 1. Then turn the other side too, turn this side. Since you turn this upside down, you have to turn this too upside down, so this will be 60, okay, over minus 1. I think this will be more efficient than cross multiplying. This is easier to handle than cross multiplying. V divided by 1 is V, equals to 60 divided by minus 1 will be minus 60. Because this 60 here is positive, okay, it is plus. And when you do plus divided by minus, you are going to get minus. Now this is minus, this is negative. When you have a negative image distance, what does that tell you? It tells you that that object is virtual. Okay, virtual images, that image is virtual. Virtual images have negative image distance. Okay, it has negative image distance. So it means that the image here is going to be what? Virtual, and it is going to be formed behind the mirror. Virtual images are also formed behind the mirror or the lens, as the case may be. So it is virtual and 60 centimeter behind the mirror. Okay, now there are even ways by which you could have solved this question without even calculating. If you look at the focal length here, okay, it is 20. right? The focal length is 20, and the object distance is 15. Meaning, let's say we have that concave mirror like this, we have the concave mirror like this. The focal length is 20, okay, and the object distance is what? Is 15. It means that they have placed the object between the principal focus, okay, and the pole of the mirror. And what happens when you place an object between the principal focus and the pole of a concave mirror is that you are going to get a virtual image. That image is going to be virtual, okay. You are going to get a virtual image. So I could easily say that, oh, the image is going to be virtual, but the point is, what will now be the distance? What will be the distance? But if you look at this option, I also said that virtual images are formed where? Behind the mirror. This is the behind of the mirror, okay. This is the back of the mirror. So this is where the image is going to be formed if it's a virtual image. If you look at this option here, they said front, okay, front. So this cannot, I know that this cannot be the answer. This cannot be in the front. So I'm now left with what? Virtual and this. So this cannot be my answer. So I now have to undergo all of this stress. But that is if you actually understand the theory, like the theory behind this, okay, this work here. So then you can do it this way, okay. Next question on laws of motion. All of these statements are examples of Newton's third law of motion, except the force, okay, force due to rotating helicopter blade. This does not apply to this is not a deduction. This is not something that is directly connected to Newton's third law of motion. Newton's third law of motion states that action and reaction are equal and opposite, okay. That action and reaction, they are equal and opposite. For example, like let's say you are using a rope, okay, to lift a bucket. You attach, say, a rope or something to a bucket, and then you pull, that bucket with that rope. The weight of the bucket and the tension in the rope is an example of two opposing forces. The weight of the body is downward, the tension is like upward, okay. So that's an example of an action and reaction of force. But and that applies to these other options that I have here. A person jumps out of a free canoe. So what happens as the person jumps out of the free canoe, the canoe is going to be pushed back because the person is jerking forward. So as the person is jerking forward, okay, the canoe will jerk back, okay, as a reaction to that. Also, a cyclist riding along a level road, okay, and a teacup, that is a teacup is preferred to a thing or when drawing water from the well. Why? Because you need to consider the weight, okay, the weight of that water they are drawing. So if you are drawing water with a thin rope, it will cut. Why? Because the tension will be too much for that rope to bear, okay. It will be too much so from your understanding of Newton's law of motion, you understand that since you are going to have like since the bucket of water is weighty, okay, that bucket that is going to draw water, since it has weight, then you need a really thick rope to pull it, okay. So that is still something that is connected to the Newton's law of motion. But here, force due to rotating helicopter blades, no connection. But there is no apparent connection, I should say. Next, on gravitational field, if the mass of an object on the face of the earth is A, the mass of the earth is B, and the radius of the earth is R, the force of next one is calorimetry. Calculate the quantity of heat required to change 2 kg of water at 0 degrees Celsius to water, okay, at 100 degrees Celsius. That is to raise the temperature to 100 degrees Celsius. And I'm giving the capacity of water as 4,200 joules per kilogram per Kelvin. Alright, so the quantity of heat is given as mc delta theta, where this m here is the mass of the substance, okay. C here is the capacity of that substance, and the delta theta here is the change in the temperature. So the mass of the water here in the question is 2 kg times its specific capacity, okay, that is of the water, is 4,200 joules per kilogram per Kelvin, times the change in temperature is going to be the new temperature minus the old temperature. That will be 100 minus 0, so you have 100 here. By the time you multiply all of this, 2 times 4,200 times 100, you'll be getting 840,000. Okay, 840,000. And when we write this in standard form, this will become 8.4 times 10 raised to power. How do you know the number that is going to be here? Since we have put the points here, then we are going to count from here to the end. 1, 2, 3, 4, 5. So this will be 10 raised to power 5. If I put the points here, if I write 84.0, then I'll count from here. 1, 234. So it's going to be 84.0 times 10 raised to the power 4. But because if you look at the options that we have here, the point is between 8 and 4. So we put the point here, 8.4 times 10 raised to the power. We then count from the point. 1, 2, 3, 4, 5. 10 raised to the power 5. We have our website at scholar.com where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry, and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scholar.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. Next, on machines, what is the velocity ratio of an inclined plane which makes an angle of 60 degrees with the horizontal? So in an inclined plane, the velocity ratio is given as 1 over sine theta, where theta is the angle of inclination. So for this here, it's going to be 1 over sine. The angle of inclination here is 60 degree, and sine 60 degree is equal to 0.8660. So 1 divided by 0.8660 is equal to 1.15. And when you approximate this, okay, this is up to 5. So you round it up as 1 and add it to the number before it. So you have 1.2 approximately as the correct answer here. Next, on current electricity, the nickel ion accumulator is a secondary cell and it has, comparatively, it has a longer lifespan than the lead acid accumulator. Okay, the nickel ion battery is it lasts longer than the lead acid accumulator. Next, on fluid properties, which of these is correct about mercury in a capillary ball? Okay, mercury is convex. The meniscus of mercury is convex, as you can see here. So this is mercury, okay, and this is a capillary tube here. You can see the meniscus. It is what we call a convex meniscus. When it curves like this, it's a convex meniscus. But for water, it is concave. Okay, so it is convex. Also, mercury does not wet glass. It does not wet glass. Okay, and the angle of contact is obtuse. The angle between this curve here and the tube that we have here is an obtuse angle. So the meniscus is convex, okay, and the angle of contact is obtuse. But for water, the meniscus is concave and the angle of contact is acute. It is concave and the angle of water is acute. Next, a car moving with a speed of 90 km per hour was brought uniformly to rest by the application of the brakes in 10 seconds. How far did the car travel after the brakes were applied? So here we have the initial speed of the car with which it was moving before it was brought to rest. That is 90 km per hour. Now the final speed of the car after it was brought to rest, okay, the final speed, since it came to rest, it means that the new speed, the final speed, is going to be 0. Okay, when the body is at rest, its velocity is 0. Okay, so the final speed v is going to be 0, and the time taken for this is 10 seconds. So the question is, how far did it travel after the brakes was applied? Okay, so now since our velocity is in meter per second, our unit needs to be balanced. The final speed here is we are expressing it in meter per second. Why? Because the time that we are given here is in seconds. Okay, it is in seconds. However, this initial speed that we have is in kilometer per hour, so we need to convert it to meter per second. Now 1 kilometer per hour is equal to 0.2778 meter per second. 1 kilometer per hour is equal to 0.2778 meter per second. How did we get this value here? Let me show you. So what we have done here is that 1 kilometer per hour, pardon the ink, 1 kilometer per hour, you can write it as 1 kilometer, okay, 1 kilometer over 1 hour. You can write it as 1 kilometer over 1 hour. The next we are now going to do is convert this kilometer to meter. Now 1 kilometer is 1000 meter, so this 1 kilometer is going to be 1000. Okay, 1000 meter. Then convert this hour to seconds. How do you convert to seconds? No, we cannot go directly from hours to seconds. Okay, we need to convert first to what? To minutes rather. Now this is 1 hour. So if you convert 1 hour to minutes, how many minutes do you have in 1 hour? That's 60. So 1 hour is going to be 1 times 60. Now the time here is in minutes. Okay, we then need to convert it to seconds. How do you convert to seconds? How many seconds do you have in a minute? 60. That means that we need to multiply this again by another 60. So we now have the time in seconds. So this is now equal to 1000 meter. Okay, 1000 meter divided by 1 times 60 times 60. That will give us 3600 seconds. So when I now do 1000 divided by 3600, that's when you are going to get this figure here, is 0.2778. That is 1 kilometer per hour. So what will now be 90 kilometer per hour? If 1 kilometer per hour is this, then 90 kilometer per hour is going to be what? We just multiply this figure here by that 90. Okay, we just multiply it by 90. So we are going to have 90 times this, and that will give us 25.002 meter per second. So what we have here is not very significant. So we just take this part here, just this 25 meter per second. Then we now calculate the deceleration. Okay, using the first equation of motion, that v is equal to u plus at. So we have our v as o. Okay, the final velocity when the body came to rest is 0, equal to the initial speed, which was 90 km per hour, but we converted it to meter per second, and so we have 25 meter per second. Okay, then plus acceleration, which is what we are looking for, then times the time, which is 10 seconds. So from here we now have, what we now do is bring this plus 10a, bring it to this side here. Okay, bring it to this side here. So it's going to become minus 10a is equal to 25. We then divide both sides by what? By 10. By minus 10. So we are getting minus 2.5. That's 25 divided by minus 10. That will be minus 2.5. The reason why we are having this minus here is because this is deceleration. Deceleration is a case of negative acceleration. That's why I have this minus. We can now go and use another formula. So we've gotten the acceleration here. Okay, we've gotten the acceleration, or the deceleration rather. We can now use another formula, this formula here, the third equation of motion, to find the distance, which is what they asked us to find. How far did the car travel? The distance. So you say v squared is equal to u squared plus 2as, where this s is the distance. That's what we are looking for. So you say v is of course 0. Okay, is 0. So you have 0 squared is equal to u, which is 25 after our conversion here. So you have 25 raised to power 2 plus 2 times, okay, our deceleration is what? Minus 2.5. Minus 2.5, then s. So we have, this is 0 is power 0 is 0, meaning 0 times 0, that's 0. 25 raised to power 2 is 25 times 25, that is 625. Then plus 2 times minus this, we have minus 5 seconds. We can then bring this minus 5, we can bring it to the other side, so it becomes plus 5. Okay, so we have 5 seconds. Then to get our x, we are going to divide both sides by 5. When we divide both sides by 5, s is equal to 125 meter. Next, on elasticity, a piece of rubber 0.2 meter long stretches by 0.01 meter when a load is hung on it. Calculate the strain. So the strain is the extension over the length. Now the original length, they said a piece of rubber is 0.2 meter long, so that's the original length of that piece of rubber, that is 0.2. They said stretches by 0.01, meaning this is the extension in this length, the extension of this length when a load is hung on it. So the extension here is 0.01. So just say strain is extension over length, so it's 0.001 divided by the original length, which is 0.2, and that will give us 0.05. Next, what part of the camera performs the same function as the retina of the human eye? So the retina of the human eye is where the image are formed. Okay, that's where the image is focused, that's where it is formed. And in the camera, it is the film. Okay, the film, that is where images are focused in the camera. So it performs like the same function. Its function with that of the retina is analogous, that images are formed on the film in the camera and the retina in the human. You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2, or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to write the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, it could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scholar.com, or you could also check it out in the video description below. Next, on fluid properties, the temperature at which the water present in the atmosphere is just enough to saturate the air is. That's how you define a dew point. The temperature at which water present in the atmosphere is just enough to saturate it. Next, on waves, from the wave property V is equal to F lambda, the property of the wave that is independent of the other is, that is F. The frequency here is an independent variable. Okay, it does not change when the wave moves between two media, but the velocity and the wavelength can change. Next, on electronics, an alternator can be made into a dynamo by changing the rings to a commutator. Okay, by changing the slip rings on it, okay, to commutator. Next, on magnet and magnetic field, the magnetic flux density of a 10-meter long stiff wire carrying a current of 4 ampere is 0.8 Tesla. Calculate the force if it is lying in a direction at 30 degrees to the magnetic field. So as to calculate the force. Okay, so the force is going to be given as B, the magnetic flux density, times I, the current that wire is carrying, times its length, sine theta. So the magnetic flux density here is 0.8 Tesla, times the current that the wire is carrying, which is 4, times the length, which is 10 meter, sine the angle of inclination here is 30 degree. Okay, so 0.8 times 4 times 10, sine 30 is 0.5. Okay, is 0.5. So when you multiply all of that, 0.8 times 4 times 10 times 0.5, you'll be getting 16 Newton. Alright, final question also on electronics. If a donor impurity is introduced into a silicon lattice, the resulting material is going to be an N-type silicon. Okay. Now, to begin with, the addition of impurities to a semiconductor is what we call doping. It is called doping. Okay. And the essence of doing that is to increase the conductivity of that semiconductor. Okay. Now, depending on the nature of that conductor, okay, we can have an N-type, semiconductor, or a P-type semiconductor. Okay, so a donor impurity is a dopant, okay, that has 5 valence electron when doped with a semiconductor. Okay, and because it has excess negative charge, because that dopant has excess negative charge, it will form, okay, a N-type semiconductor, which is what we are using here, a donor impurity. So you'll be getting an N-type semiconductor. But if you use an acceptor impurity, which has 3 electrons in its valence shell, okay, that is 3 valence electron, due to the presence of excess positive charge, you'll be getting a P-type semiconductor. So since we are using a donor impurity here, we'll be getting an N-type semiconductor. All right. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at scholarfedu. Okay, like and share our content, and visit our website at scholar.com to practice UTME exam and modular quizzes for free. Thank you.